Yeah, yeah.
So this is going to be our session 2 in the architecture part. So
Okay,
the
okay, sir.
name architecture, it is just for my convenient. I have made it like architecture, but it's not like
Okay,
this is the things going to be architecture in MongoDB, because if you
okay,
Google it in Google it, or if you read from the MongoDB manual document, nowhere you will find like architecture.
okay,
They
sir.
haven't come up with any architecture part because they made it all the stuffs to automated. We don't need
Okay,
to manually intervene anything, something like that they
okay,
are
okay,
automated. So but still there are some things to know, the storage engines, journaling, those topics I have related to Oracle architecture. Okay,
okay, okay,
and then I have made it the topic as architecture.
okay, sir.
Okay, so the storage engine layer, if you see in the top boxes, it's a IoT sensor backend, AD service, customer analytics, archive. These are all the applications. Okay.
Okay,
Behind the application, there is one layer called MongoDB query language. That is, we are using
okay,
a Mongo shell and other stuffs. Okay.
okay,
So the
okay, okay, sir.
application will use MongoDB query language with a native driver.
Okay,
For every
okay,
programming language, there will be one driver. If you are
okay,
connecting through if you are connecting through Java program, then you need to use MongoDB Java driver. If you are
okay,
connecting to .NET, then you need to use MongoDB .NET drivers. So
okay,
MongoDB, they have provided, and they are giving drivers for each and every programming language, even for Perl
okay,
and other PHP, and for most of the programming language, they have come up with the drivers. So you
okay,
need
okay,
to use your programming language with these native drivers to connect to the MongoDB. So next
okay,
comes the MongoDB document data model. Here comes our document storage. We are viewing like db dot collection dot find. It is displaying the
yes,
documents and all those stuffs. For a single database, there will be a multiple collection, and on each collection there will be a number of documents. This is kind of a data
yes, sir.
model we have in MongoDB.
Okay,
So this is the data model layer. So behind that,
okay,
we are having storage engines. So the storage engines, it's nothing but how physically the MongoDB stores the data in the
okay,
OS. That is the concept of storage engines. So in
okay,
Oracle and other DBMS and all, we do not have this kind of multiple storage engines. Uh,
okay,
it, uh, the database itself will take care of the storing the files and everything.
okay, yeah, sir.
Okay, but here it is not like that. We have a different storage engines. So the earlier one is like up to version 3.0, MMap V1 is the default storage engine. Okay,
Okay,
but in 3.0, WiredTiger is a optional storage engine. If you want,
oh,
you can use WiredTiger as a optional storage engine.
okay.
But at a time
Sir,
you
what
can
is
use
MMap?
MMap is memory mapped files.
Memory mapped files. Okay,
Yeah, memory mapped, it's a version 1 file, something like that.
okay,
MMap is developed by MongoDB, that MongoDB Inc. But WireTiger is developed by a different company. After later time,
okay.
they have acquired that one, and then they are using in MongoDB.
MongoDB. Okay,
Yeah. So WireTiger from version 3.2, WireTiger storage engine is the default storage engine.
okay. From 3.2.
Yeah, from 3.2,
Okay,
WT is the default one.
okay, okay, sir.
So apart from this MMap and WireTiger, we have some other storage engines as well. That is
Okay,
in-memory storage engines. Like you might have heard
okay,
about in-memory databases. Few databases,
okay,
I don't know the exact name. I think Amazon DynamoDB is in-memory database, I guess. So similar to
okay,
that, there are few databases are there. They are called as an in-memory database. Okay.
okay,
So similar to that, MongoDB also providing in-memory storage engines.
okay,
It is like all the data and indexes completely 100% all the data and index will be there in the RAM memory, not in the disk.
okay,
So few use cases, few applications need those kind of memory. In
in
memory
memory.
storage engine. Yeah.
Okay.
so that only they can do a fast read and write, because
Okay.
always reading and writing in disk is um, it will take time, right, when you compare to reading
Yes,
and
sir.
write from memory.
Yes, sir. Yes.
So for to provide those kind of to support and to solve those kind of use cases, MongoDB come up with in-memory storage engines that is available
Okay.
in 3 point from 3.2 onwards.
Okay.
So these future possible storage engines, they call it as maybe in future they maybe come up with new storage engines to solve new use cases.
Okay.
Okay, I guess from in 3.2 we have another storage engines. It is called as encrypted storage engine, I guess. Uh,
Okay.
so these are all the three which are, I mean, it is largely used in the organizations. But mostly, if you
Okay.
see, 90% they will see, they will leave it as whatever the default storage engine.
Okay.
From until 3, they will leave it as MMap. When it comes to 3 point,
Okay.
they will leave it as a WiredTiger.
Okay.
So apart from this, we have
So,
other.
sir, what I understood with this is storage engine is one type of an application which takes care of all the storages underlying means underlying storage, whatever how to store the MongoDB data. It will take care by itself, right? With
Yes, yes,
some
yes.
some type of code.
Yeah, exactly. It's kind of
Okay.
software you can say, or
Okay.
framework, whatever you can say. It will
Okay.
take care of the storing that data whichever comes into the database
Database.
in the
Okay.
file system. Yes.
Yeah.
Also, it will provide the compression, encryption, um, locking. All those stuffs are handled by the storage engines only. Depends upon which
Okay. Okay.
storage engine you are choosing, you will get
Okay.
those kind of locking, compression, encryption. That will vary for each storage engines. So we are going to talk
Okay.
about each in detail. So
Okay.
the additional layers are security and management. This is are in the all the layers. Security, you can have set it in the storage level, in the document data model level. So everywhere you can do the security settings. And management also, you can
Okay.
manage the files in the OS level, in the inside the database. So this is a support layer.
Okay. Okay.
So if you see, as I said, these are all the three storage engines we have. So first of all, what is storage engine means? It is responsible of managing how to store the data, both in memory and
Okay.
disk.
Both in
Not only
memory
in
and
disk,
on the disk.
not only in the disk, but also in memory as well. So
Okay.
it depends upon your storage engine, it will vary.
Okay.
Okay, the WireTiger, which is the default from MongoDB 3.2. Uh,
Okay.
Actually, when you compare to MMap, WireTiger is it will perform very well, both in
Okay.
performance wise as well as it will give you a lot of compression. For
Okay.
example, I can say we had one database around 600 MB. It's only
Okay.
small. No, I think it's 6 GB. Okay, the
Okay.
database is very small database, but
Okay.
it was there in the version 2.0, 2.6. We upgraded to
Okay.
3.0 with mmap v1. Again, we upgraded to 3.2 with WireTiger as the default storage engines. When we
Okay.
upgrade from 3 to 3.2, the 6 GB
Okay.
data file got compressed to 600 MB.
Oh,
So the,
okay.
it has done 10 times compression,
Okay.
but still it has provided the same performance and other benefits.
Okay. Okay. So internally it is compressing, but while we are querying it, it gives the same output as well as in the same time also.
Yes, exactly.
Okay.
That much powerful, that WireTiger storage engine.
Okay.
So apart from compression, WireTiger provides document level concurrency model, that is document level locking. If you say MMap
Okay.
v1, the locking is at the collection level, but
Okay.
in WiredTiger the locking is document level. So what is the
Okay.
difference between these two is, when you have a locking at the collection level, so let's say you are updating one document inside a collection.
Okay.
In 3.0 with the mmap, if you are updating one document in a collection, you will not be able to
Uh,
uh, you will not be able to update other documents because the locking
yeah.
is
Yeah.
happened at the collection level.
Connection. Yeah. Connection. Yes.
Okay, but when you come to WireTiger, the locking is at the document level. So,
Okay.
let's say you have a 10 documents inside a collection. If you are updating a first document, still you will be able to read and write the other documents in the same collection. So that is the
Oh.
difference in locking level.
Sir, lock means like while someone is performing some update, there will be some like when you compare it to RDBM as when someone are updating one for example few rows, there
Hmm.
will be some lock or there.
Yes, yes.
Lock or latch, whatever you
Yeah,
say.
yeah, yeah.
So if like in MMAP,
Hmm.
if one is updating one document, whole of the collection will be logged.
Yes,
And in WireTiger, if one is updating one document, then the only that document will be logged, and other documents are readable and as well as writable also.
exactly. 100% true.
Okay, sir. Yeah. Yeah.
Okay, so that
Okay, sir.
document level locking and then compression and then checkpointing. Checkpointing we will talk about when we discuss about journaling. So checkpointing
Okay.
is the other benefits which is come up with
Okay.
WireTiger, and as apart from that it is providing encryption at rest. WireTiger
Okay.
also supports encryption at rest. It means on the OS, I mean OS file system level, it encrypts
Okay.
the files. If you
Okay.
want, if you enable encryption, it does the encryption as well.
Okay. Okay, sir.
Okay, mmap v1, which is the default storage engine before 3.2. That means until
Okay.
3.0, it is the default one. It is also a good one for the read and writes. But compared to mmap, WireTiger is the best one. So
Best one, yes.
yeah, the in-memory storage engines, as I said, it is like storing documents and indexes, I mean data and indexes in the memory
Okay.
for the better performance.
Better performance, okay, sir.
Yeah. So this is the details about the WireTiger storage engines. So WireTiger, as I
Okay.
said, it is providing document level concurrency control. It means multiple clients can modify different documents of a collection at the same time. Inside the same collection,
Okay.
multiple clients do read and write.
Okay.
For that, they are using multi-version concurrency control.
Okay.
So for every transaction, when it is starting, it will create one snapshot.
Okay.
Okay. Using this snapshot, only we can provide the consistency.
Okay.
So when the operations are happening in the memory, uh,
Okay.
it will, for each and every operation it will create a snapshot, as well as for a certain duration it will create a checkpoints. Checkpoint,
Okay.
you have read in Oracle, right? The same
Yes,
concept
sir.
here, just to have the consistent view.
Okay.
It is a recovery point, it will act as a recovery point as well.
Okay. Okay.
We'll be doing, right, when we have a checkpoint we'll be having SCN number in Oracle. So based on that
Yes, sir, sir.
SCN number and then timestamp we will be doing restore and recovery, right?
Yes, sir.
Yeah, similar to that. So when it is writing in the memory itself, it will have the snapshot, how to have each and every operation in the consistent, as well as it will create the checkpoints, and it will write
Okay.
it into the data files.
Okay. So, sir, what I understood is like through WiredTiger,
Hmm.
when one is updating a document,
Hmm.
first the snapshot of that document is taken and it will be in the memory. Once he has updated the document,
Hmm.
then that snapshot will be updated as well as it will be updated and the checkpoint occurs and it will update the old data with the new data, right?
Yes.
Okay. Till that point, when someone some XYZ is updating a document, that old snapshot, if someone wants to read that document, that
Hmm.
snapshot will be read by that ABC some ABC guy who wants to just read that document.
Yeah.
Okay.
So so the snapshots are created for every operations, like whatever the insert, updates, deletes comes, for every operations, the snapshots will be created, and
Okay.
when the checkpoints occurs, that time only it will be written into the disk. So when the checkpoint
Disco.
will occur, it is like the interval of 60 seconds or 2 gigabytes.
Okay.
Okay, for
Okay, sir.
every 60 seconds it will write it into the disk. That means for every 1 minute it will write into the disk. Otherwise, before 1 minute, if the data reaches more than 2 GB, then it will write it into the
2G.
disk.
Okay, sir.
Okay.
Oh yeah.
So if you see, the first checkpoint will be, let's say, you have one operations which is happening in the memory, and that
Okay.
comes to journal. From journal, 60 seconds got over, so that that snapshot is written into the disk with the
This.
checkpoints. Okay, let's say
Okay, sir.
checkpoint number is 10. Okay,
Okay.
again after 1 minute it is writing another operation, and then another checkpoint with the checkpoint, let's say it's 11. So
Okay. Okay.
still that 11 is written into the disk, the 10 will be valid checkpoint in the disk.
Okay,
Why
sir.
it is valid means something crashes in the some unexpected crashes happens in the server, then
Okay.
when the MongoDB is getting restarted, it will read the checkpoint number in the disk. What is the last valid
Okay.
checkpoint? Let's say it is
Okay.
10. Okay, so it
Okay,
will
sir.
start from it will start the database up to the snapshot, the checkpoint 10.
A valid checkpoint. It will start at till that point. It will bring up the system and it will be there.
Yeah, if you do not choose journaling, then the I mean, anyway, we'll talk about that part in journaling part. Okay,
Okay.
you'll be
Okay,
clear
sir.
at that time. So anyway, here we'll be talking about how those things are handled with
Okay,
journaling
okay,
and
sir.
without journaling.
Okay.
Now I'll just give the overview and the futures of WireTiger storage engines. Okay, leave about this,
Okay,
how
sir.
the data are written and how the data are recovered. This point
Okay,
we'll
okay,
leave
sir.
about now.
Yeah.
This the first 2 points again the same, again the same journal and how the data is written and recovered. The next is like,
Okay.
as I said, MongoDB supports compression for all the collection and indexes. Okay,
Indexes. Okay.
yeah.
Okay, sir.
The default compression is snappy compressions. There are two compressions there in the MongoDB. One is snappy and another one is zlib. Is that lib?
Uh-huh.
Okay, the default one is snappy compression.
Okay.
The snappy compression provides less compression and then more performance.
Okay.
Okay, when you come to zlib, it will give you more compression. and it
Okay.
will give you less performance. So depends
Less
upon your
performance.
use case, your need. You can choose which compression you want.
Okay.
Okay.
Oh, okay, sir. Sir, like once we are pumping the data into the data disk, I
Hmm.
means in the disk, so automatically we must not say explicitly like compress this data or don't compress the data. It automatically compresses the data, sir.
No, no, no. If you enable, then only no, no. This one compression it will happen by default. The snappy
Okay.
compression, it is a default one.
Okay. Okay.
Okay, from 3.2, the default storage engine is WiredTiger. WiredTiger by default it does the compression with the snappy.
Okay. Means what I want to say is like if we are sending 10 files of 10 MB.
Okay.
So if we have to configure that compression at the MongoDB level, or else it will automatically, whenever the 10 MB is coming in, it will not even ask you like whether to compress or not. It will automatically compress it and it will put it in the disk.
It will automatically compression. It will have in the disk.
Okay, okay,
That's
sir.
what I have given one scenario, like when we have upgraded, when we had a 6 GB of data, it got reduced to
Okay,
600 MB. We didn't do anything. We didn't change
okay,
any
sir.
compression parameters and other stuffs.
Okay,
Okay.
this is a great advantage for
Yeah, yeah, yeah.
new databases.
Exactly. So there are two catches there in the WireTiger. So
Uh-huh.
uh, this is how that your RAM memory is used. That is WireTiger internal cache and then file system cache.
Okay,
This is all about the RAM memory, not
okay,
the file system cache. It is a RAM memory. So
okay,
by default, your 60% of RAM minus 1 GB is considered to WireTiger internal cache
okay.
or 1 GB, whichever is larger.
Larger. Okay.
So, so if you are planning and if you are setting up a new environment, you have to make sure
Okay.
WireTiger internal cache will take 60% of RAM minus 1 GB. You have to
Okay.
plan accordingly.
Okay. Minimum it is 1 GB or else 60% of the RAM.
Yeah.
Okay.
So the file system cache, whichever the RAM is, I mean, as I said, WireTiger internal cache uses uh, 60% of RAM minus 1 GB. So the remaining
Okay.
RAM memory will be used for file system cache.
Okay.
Got it?
Yeah, means file system means our underlying Unix system.
Yes, but this cache is used by MongoDB. This is not the one with we are talking about OS file system.
Okay. Okay.
They have a
So
two name.
not it's like we are installing MongoDB on a Unix server, right,
Yeah,
sir?
yeah.
Like for example, it has 4 GB of RAM.
Yes.
So MongoDB is using 2 GB. For example, MongoDB is using 2 GB and other 2 GB is used by the underlying OS.
Okay.
So 60% of 2 GB memory, RAM memory
No,
is
no, no. It's not.
occupied by
No,
WireTiger
not like
internal
that.
cache.
No, no, no.
Okay,
So let's say you have a 4 GB of RAM in your system. Okay.
okay, sir.
When you are starting itself,
Okay,
MongoDB will take care of 60% of RAM minus 1 GB. That is
okay,
60% means 2.4 GB minus 1 GB. That is 1.4 GB.
okay, okay, sir.
So MongoDB internal WireTiger internal cache will take care of 1.4 GB. So the remaining
Okay.
RAM memory is 2.6, right?
Oh yeah.
In that, let's say OS is using 1.5 GB.
Okay.
The remaining is 1.1 GB. That is used by
Yeah.
file system cache, MongoDB file system cache.
Okay. Okay. MongoDB. Okay. Okay.
You understood, right? So
Yes, sir. Yes, sir.
MongoDB WiredTiger internal cache, when you are starting itself, it will calculate and it will take that much memory
Okay,
for
sir.
its own purpose. If you
Okay.
do not have enough memory, it won't start.
Okay.
Okay. So this is
Okay, sir.
kind of a sample YAML configuration. We have seen that MongoDB.conf file, right?
Yes, sir. Yes, sir.
We've set some storage, there are DB, path,
Yes,
and
sir.
other stuffs.
Path for log,
Yeah,
data
we have
path.
left other as a default one. So if you want to
Yes.
change storage engines, like suppose you are setting up version 3.0, but you want to
Okay.
use WireTiger as a storage engine. But by default,
Okay.
storage engine is MMap. If you want to change
Okay.
to WireTiger, then you need to go and check set this YAML file with this sample setting, storage,
Okay. Okay.
WireTiger, and the engine config. You can mention the cache size GB.
Okay.
So this one's the default is 60% of RAM minus 1 GB. But if you want to
Yeah.
change, if you want to give more GB or less GB, you can configure here.
Okay. Okay, sir.
And then channel
Okay, sir.
compressor. So do you want
Okay.
to the next is journal compressor. It is
And means snappy compression or
yes,
zlib.
zlib compression. Yeah,
Yeah.
that is for journal files, not the data files.
Okay.
What is journal file? We'll be talking in the next slide. So
Okay. Okay. Okay, sir.
this is to make sure whether you want to compress the journal files or not. And then
Okay,
directory
sir.
for indexes. Um, okay, I'll give you a demo as well as
Sir, before I forget, I want to remind you,
yeah.
like yesterday you have uploaded the videos, right?
Yes, I uploaded, man.
Yeah, yeah. I have able to download it, sir. I have given the permission, right?
Yeah.
So once you upload it, just right click on it, sir.
Okay.
Right click on it and then just click on share. It will ask you the email ID.
Okay.
So there you give the email ID. I will. It will automatically give me the permission.
But I have given the permission, man, already
Okay, okay.
for
But
the
I
for
don't know,
your
sir, why it was asking me. Like, I think you have given for yahoo.com, I think so.
1 minute. Ravi.
Yeah, yeah, sir.
Actually, I have given permission to your Gmails as well, but I have given after
Okay.
10 o'clock, I guess.
Okay, okay.
Maybe you check today and then you SMS me.
No, no, no. I was able to download it, sir. Like after giving the permission.
Okay.
So I thought like from for today's one, like I just right clicked on the video.
Hmm.
There was an option called share.
Yeah, yeah. If I do share, um,
Yeah,
yeah, you will get the link and then you can open. But
yeah, yeah.
what I have given is for the whole directory, I have given the permission to
Okay,
you.
okay,
Okay. So whenever
okay,
I upload some videos inside that directory, you can
okay,
directly go and download it.
okay, sir.
Okay.
But it was yesterday. It was asking you. That's why I was disturbing you
Yeah,
in
yesterday
the
initially
middle of
I've
it.
given to you only your Yahoo email ID. Later,
Okay,
once I've seen your SMS, later
okay,
after 10 o'clock only I have given permission to your Gmail ID.
okay, okay, sir.
That might be
No
the
problem.
problem.
Yeah, because it was whenever I open it, it is going to the Gmail itself because it's a Google Drive, right?
Yeah, yeah.
So that's a problem.
Okay, okay.
Oh,
So if you check here, by default, you will not have directories for indexes and collections,
yes, sir.
right? Inside
Yeah.
the data directory, all the collection and indexes files are getting created.
Yes.
Okay. So
Yeah.
to avoid that, if you want to have a one directory name called a collection and one another directory name called index, and you want to have all the files inside there,
Okay.
you can enable this option, directory for
Okay.
indexes.
Drive to find access. Okay.
Yeah, and then collection config block compressor.
Okay.
This is used to tell you you want to use compression for the data files.
Okay. Okay.
Here also you can mention either snappy or zlib.
Okay. Okay, sir.
And then index config prefix compression. It is like it's kind of a compression used for index.
Okay.
Mostly these stuffs you can leave it as a default one.
Okay, sir.
Okay, now we are going
Okay.
to talk about this one, journaling.
Journaling.
Okay, journaling, it's
Okay, sir.
a kind of an important thing to know
Okay.
in MongoDB. So what is journaling
Okay.
means? It it is like a log file that is used to recover the database when the hard shutdown happens.
Okay.
Okay, I'll ask you one question. If in Oracle, if some
Okay.
transaction is going, if something happens to the server and it get crashes, so you are
Okay.
recovering that server, and so how come Oracle will recover the transactions?
In redo logs.
Yes. So what it will
In
do?
redo logs, sir.
So redo log, you are right. So what it will do from the redo log?
Like through this SNN,
Hmm.
and first it will like one background process. I forgot that once you come up with bring up the system,
Hmm.
that first it will check that background process will check whether there is any incompleted transactions,
Hmm.
and it will check the even the SSN number,
Yeah.
and
SCN number.
if yeah, SNN number, and the committed transactions are returned back to the disk, and uncommitted transactions are rolled back.
Yes. So, we are having redo logs in Oracle for doing the instance recovery. So that the SMON process
Yes.
will take care of the
Ah, yes, one.
instance recovery. So similar to
Yes,
that
sir.
in MongoDB, we have a journal files. Journal is just a file in the OS level. It will have all the transaction before it is getting to return into the disk. So when
Okay.
something goes wrong, so when again when MongoDB is getting restarted, it will check the
Okay.
journal files. If there are any,
Okay.
so what exactly it will do means, it will check the checkpoints in the disk file. So let's say the checkpoint is 10 in the data file. Okay.
Okay.
Again, it will check the uh, checkpoints in the journal file. Let's say
Okay.
in journal the committed checkpoint is 11. Okay,
Okay.
so
Okay.
the data file is missing with one checkpoint, so there are some transaction between 10 and 11. So what
Yes.
MongoDB will do is it will read those transactions from the journal file, and then it will apply into the disk file.
Okay. Okay.
Okay, then it will clean the
It's
journal
similar to
file.
control file and alert log file.
No, not control file and alert file. Control file, it will have the metadata of where the data files are there and other information. Alert log
Yes,
is
sir.
like
All the alerts.
yeah, all the
Means
issues and
I'm just
errors.
correlating it to those things, but
No,
it's
if you
not
want to
that.
correlate with Oracle, you can correlate with the redo log.
Okay. Redo log. Okay.
Yeah. So it is similar to redo lock in Oracle. Okay.
Okay. Okay.
So as I said, the recovery process, if you see, looks in the data file to find the identifier of the last checkpoint. In the
Okay.
data file, it will check the last checkpoint and search in the
Okay.
journal files to record the matches of identity the last checkpoint. Again, it will search in the journal file. So where that last
Okay.
checkpoint is there. And again, it will
Okay.
look for any other new new checkpoints and new operations are there in the journal file. If it is found
Okay.
some new operations in the journal file, it will apply those operations into the disk.
Disk. Okay.
So this is the process of journaling with the WiredTiger
Journal.
storage engine. Okay.
Okay, sir.
This is the image of the how that journaling and that WiredTiger storage engine works. Okay,
Okay.
if you see the write operation coming into the memory, it is creating a
Okay.
checkpoints, and then the snapshots are written to the journal files. So immediately
Okay.
the snapshots will be written into the journal file. Okay, from journal
Okay,
file
sir.
after 60 seconds only it will be written into the disk.
Okay.
So for every 60 seconds some transaction will be there in the journal files. Correct.
Okay. Okay, sir. Okay.
So if anything goes wrong in between that 60 seconds,
Okay.
those transaction will be there only in journal files, not in the disk.
Then.
So when the
Okay.
MongoDB is restarted, it will reapply those transactions to the disk.
Disk. Okay.
So this is all about how the data are written into the disk.
Okay.
This is how the
Sir, here,
journal plays
here
a role.
my doubt is like when the write process is happening,
Mm.
the diagram.
Yeah, yeah,
That checkpoint one, after that checkpoint one,
yeah.
that this snapshot is the updated snapshot, right, sir?
No, no. Before checkpoint one also the snapshot will be there, and those are also will be written into the disk. But in this
Okay.
image,
After this checkpoint, one snapshot will be there.
yeah, yeah. Before the checkpoint also snapshots will be there, and those
Okay.
snapshots will be written into the journals.
Okay.
So here you can say like in checkpoint one, there are no
Okay.
transaction.
Okay.
Okay, you can consider like
Okay, sir.
up to checkpoint one there are no transaction, zero. It
Okay.
is empty.
Okay.
When it is starting checkpoint
Okay.
one, it is empty. Again
Okay,
some
sir.
transaction are happening. Those snapshots are written into the disk. Again the
Okay.
checkpoint two is happening. Like
Okay.
that
Okay, sir. Okay.
you can understand. Okay.
Okay, sir. Okay, sir.
So from journal, so on which
Okay.
scenario the data is getting written into the disk. These are the scenarios.
Okay.
You have read in Oracle, right? On redo
Yes, sir.
buffer, when it fills one third of, it is getting written into the redo log files.
Yes, sir. Yes, sir.
So similar to that, from journal files, on certain conditions, it will be written into the disk.
Okay.
So initially I said, okay, for every 50 milliseconds.
Okay.
Okay, this is like syncing from the memory to journals, not from
Journal.
journals to disk. Okay, there are
Okay, sir.
three things. One is memory to journal, and then journal to disk.
Disk.
Okay, this is how
Okay, sir.
from memory to journal that syncs are getting happened every
Okay.
50 milliseconds.
50 milliseconds.
Yeah, but when you take when you talk about that one journal to disk, it is every 60 seconds. That is 1 minute,
Okay.
but it is 50 milliseconds.
Okay, sir.
If you want, I'll tell you here. So this is like the snapshot to journal. This
Journal. Yes, sir.
this one we
From
are
memory
talking.
to
This is
journal.
the three arrow mark are there, right? That one we are
Yeah.
talking. This will happen
Yeah.
every 50 milliseconds. But this one
Yeah.
arrow mark is there, right? It will happen every
Yes, sir.
60 seconds.
Every 60 seconds. Okay, sir.
So this is how most of the recent transaction will be there only in journals, not in the disk.
Okay. Okay, sir.
Also, uh, okay. Apart from this, every 50 milliseconds, every 60 seconds, checkpoints will be there happen in the memory. Okay.
Okay, sir.
If checkpoint happens also, that will be written into the journals.
Okay.
Okay, and then that is second one. Third one is when you are writing some transaction, that is db.collection.insert, you will be mentioning write consents. Write consent will be talking about this in replication module in detail.
Okay.
But just I'm saying there are
Okay.
some concept called write consent where you want to write, whether you want to write in primary only, whether you want to write it in primary and secondary only, whether you want to write in primary and two secondaries. Those kind of write consents will be using. So in that
Okay.
we have another option called j:true. That means write it into the journal first.
Okay.
So if you mention your insert command with the j:true, then also it will directly write into the journals. It will not wait for
Okay.
50 milliseconds.
Okay.
It will not wait for checkpoints to happen. It will directly
Okay.
write the
As and
operation
when
to
it is
journal.
written, it is already we will be there in the journal.
Yes. While
Okay.
writing in memory, it will directly written into the journals as well.
Journals. Okay.
Yeah, to make sure the transaction is not missing
Okay, sir.
before getting into written into journals.
Okay, sir.
So next is and because MongoDB is a journal. Okay, so the journal files size limit is 100 MB. For every 100 MB, it will create new journal files. Okay, so
Okay.
when it creates a new journal files also, it will sync with the memory.
Okay, sir.
So this is how the journal files will look like.
Okay.
Under DB directory, there will be one folder called journal. Inside the journal file will look like WiredTiger log dot and then sequence number. That sequence is
Sequence.
it is kind of a digits with 0, 1 and 2, like that it will
Okay.
increase. Okay, we'll
Okay, sir.
we'll
Okay.
see how that journal looks like. Okay,
Okay, sir.
so we are there in the data directory. So
Yeah.
inside the you can see one journal directory, right?
Yes, sir. So once it reaches 100 MB, it will again create a new journal with a wired underscore that padding number.
Yeah, yes.
Yeah.
You see, so WireTiger
Yeah.
prelog with 001 and then WireTiger
Yeah.
prelog 002. These are all
Yeah.
prelogs. These are all created pre-allocation.
Okay.
Before, I mean, while the MongoDB is getting started, that time itself
Okay.
it got created
Okay.
just to, I mean, to ready for accepting the transaction. It created two
Okay.
files. Okay.
Okay. Okay, sir.
So after that, this is the one which is created when we are doing some inserts. Like if you see,
Inserts.
this is created yesterday.
Okay. Okay.
Okay.
Oh, yeah.
You see, all the files are 100 MB.
100 MB. Sir, this prelog 1 and 2 will be created every day or else
No,
like it will
one
be
time when you were
one
starting
time
the
only.
MongoDB. Yeah.
Okay. Okay. because they are on the only the same time, like 410, that will be.
Yeah, that time we could have started this instance.
Yeah.
You understood, right? So what is
Yes, sir. Yes, sir.
journaling, what is WiredTiger, how it is work,
Yeah.
everything you
Okay.
understood, right? So
Yes, sir.
this is MMap view and storage engines. You don't need to complete, look into this in detail because
Mm-hmm.
now onwards people will start using only WiredTiger. But
Right.
if you are going to support earlier versions, you should be
Okay.
familiar about this one as well. So that's how
MMap.
that's why I put this as well into 2 3 slides.
Okay. So are you using WireTiger or else MMap, sir, in your office?
In our current environment, we are using MMap only because if you see,
Okay.
we have a 300 plus Mongo instance are there. Most
Okay.
of them are 99%, 90% they are in 2.6 and 3.0. Only
Okay.
few databases are upgraded to 3.2. So those
Okay.
databases are there in the older version. They are still using
Yeah.
MMap.
Okay. Means
But
300 instances or 300 databases you have?
no, 300 instances.
Okay. Means
Database.
yesterday, as you were saying, like one instance and multiple databases, right?
Yeah. Inside an instance, multiple databases will be there.
Yeah.
But instance
So for
itself,
every
I mean,
so
I'm
for
telling like
every database,
300,
they were using
300.
one instance.
No, I'm telling like 300 servers. It means like, let's say for one example, one HR database, HR application is there. For HR
Okay, sir.
application, 1 minute.
Yeah.
Ravi?
Yeah. Yes.
Yes, ma'am. So 300 servers, it means like one application will have 10 servers, like one primary, two secondary.
Acha. Okay. Okay. Okay.
So if you calculate like that, so application will be less, but the number of servers will be more.
More. Okay.
Mostly in NoSQL, MongoDB, Cassandra, for each application, we'll be using more number of servers.
Okay.
Okay, got it?
Okay, sir. Means they are not mixing this HR 1 into HR 1 and employees, all those things into separate instances. They are putting the data.
Yeah, so few application will be using sharding, few application will be
Okay.
using both sharding and replication. So if they are
Okay, sir.
using both sharding and replication, then they will be need more servers. If they are
Okay.
using only replication, then they will need some less number of servers.
Okay, sir.
But nowhere you can see only one server for MongoDB
Okay.
because always they will use with the replication like primary, secondary,
Replication.
secondary. At least they
Okay.
will
Okay.
have 3 servers.
Okay, sir.
Okay.
Yeah.
Okay. The MMap storage engine is totally different from WiredTiger storage engine because
Okay.
this MMap it is writes every 100 milliseconds to the journal files.
Okay.
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 So
Okay.
I'll show you the diagram. So this is
Yeah.
journaling with the mmap storage engine. If you see,
Okay.
the left one shows without journaling and the right one shows with the journaling. You have option to disable journaling, but
Okay.
in Oracle and all you cannot disable redo logs. But here
Yes.
you still have option to disable journals. Okay,
Journals. Okay.
if you disable journals, it will look like the first image. If you see
Okay.
MongoDB, it is writing into shared view. Shared view means memory. From memory, it is
Okay.
writing to every 60 seconds. That is 1 minute.
Everything.
Yeah, that is
Okay.
same to WireTiger.
Okay, sir.
Okay, but if you see
Okay.
with the journaling,
Okay.
The memory itself split into two parts. One is private view, another one is shared view.
Shared.
Okay.
Okay.
From private view, it is written into journal with the
Okay.
here they have mentioned 200 milliseconds, but
Okay.
the default is 100 milliseconds.
Okay.
Okay, but you
Okay,
can
sir.
change. You still you are having option to change.
Okay, sir.
Even you can change it to 50 milliseconds.
Okay.
So here from in memory, in from private view, it is written into journals. From journal again, it is written into shared view. Okay, so
Okay.
from private view,
Okay.
it is written into shared view.
Okay.
From shared view, it is written into the disk for every 60
Disk.
seconds. That is 1 minute.
60 seconds. Okay, sir.
So this is with the MMap. Here
Oh, map. Okay.
you can't see snapshot, checkpoints. Those stuffs are there, not there.
Okay. Okay.
It is all mapping the files with the memory and file system.
Okay, sir.
From memory, it is mapped to file system, and after some seconds, it will be written into disk. Those kind of
Sir,
yes,
sir,
ma'am.
sir, one thing like I want to understand like this MongoDB and in the first this
Hmm.
left hand side this MongoDB with shared view this all comes under this MongoDB server.
No, MongoDB, which is it is running in your server. Shared view is it
Okay.
is how much memory it is using for RAM memory it is using. That is called a shared
Yeah.
view.
Yeah. No, no, no. But my doubt is like this slash data slash DB.
Hmm.
This is underlying storage, right? These are slaves.
Yes.
And this MongoDB and shared view are the master, wherein MongoDB is a server and shared view is its memory, master's memory.
No, how come here that master slaves are came into picture? We are talking
Okay,
about
huh.
a single server.
Single server. Okay, huh. No,
So
I was thinking in terms of a replication and all those things. So I thought that
please,
this.
Ravi, I'll clarify you. Do not mix up replication sharding concept here. That is
Okay,
totally
okay,
a different concept. That is high
okay, okay,
availability
sir.
and
Okay, sir.
scaling purpose. Do not mix up here.
Okay,
If you mix up here, you will confuse yourself and you will not understand anything properly.
okay,
We
sir.
are
Okay, sir.
talking about single server. For
Single
that
server.
only, I
Okay,
have created only a single machine and I am just showing
okay, huh.
on single machine demo.
Okay, sir. Okay, sir.
When we have a section to talk about replication, we will be creating
Okay,
multiple machines and we will be mixing with the this one single machine. That time
single mission.
you
Okay,
will come to know how the replication works.
okay, okay, sir.
So as of now, this is a single server. In single
Okay,
server,
sir.
we have two options. Either you can
Okay.
enable journaling or you can
Disable journal.
disable the journaling. The first image shows
Okay, sir.
with the journaling is disabled.
Disable.
Okay, that's why we have
Yes.
only the data directory path. In that,
Okay.
so MongoDB will instance which is running. It is using the
Okay.
memory, RAM memory. It is called shared view. From shared view,
Okay.
it is directly written into the data directory. But when
Data.
you enable journaling,
Okay.
intermediately there will be one file called journal. So the data will be written into journal first. After that only it will be written into the disk.
Okay, sir.
The purpose of having journal is if something goes wrong uninterruptedly or something goes wrong without our knowledge, so the database can able to recover those transactions from the journal files.
Okay, sir. Okay, sir.
So the journal is there both in MMap and WiredTiger, but the
Okay,
way
okay,
it
sir.
is functions it is different.
Okay.
The number of
And one more
milliseconds.
thing, sir, here, like we have this committing the transactions or once the transaction, that type of terminology is not there. Like once the once the transaction is committed, then only it will be returned in the journal, right?
Yes, but here in MongoDB, there is no concept called commit and rollback. It means like whatever
Okay.
the insert, update, delete you are doing, they are directly committed.
Okay. Okay. Okay, sir.
After that seconds,
Okay, sir.
In WiredTiger it is 50 milliseconds. After 50
Okay.
milliseconds it will be written into the journal files. After 1 minute it
General
will be
files.
written into the disk.
Disk.
Yeah,
Okay, sir.
straight away it will write. It will not wait for
Okay.
commit command and all.
Okay.
Okay, this is the same theory. MMap we have the it will write every 100 milliseconds to the journal files and it will write into the disk every 60 seconds. So that is
Okay,
one
sir.
difference. The other difference,
Yeah.
the files will be created uh, power of 2. Like power of 2 means first it will create 32 MB of file, and then
Okay.
when it reaches it will create again 64 MB file. When it is filled again it will create 120 MB of file. So like that it will grow
Okay.
up to 2 MB. So
Okay.
this is for data file I'm talking, database file.
Okay. Okay.
So here we have database files, right? For each
Yeah.
collection it is created one file. For
Well,
collection 0 it has created one file, and collection 2 it has created one file.
yeah.
For index it has created one file, right? But in
Yes, sir.
mmap it will create file for each and every database, not for each and every
Okay.
collections. For each
Okay.
database it will create one file. If that file,
Okay.
it will initially it will create 32 MB file. If that file got
Okay.
filled, it will create 64 MB file. Like that, it will go
Okay.
up to 2 GB. They made it wrong.
Okay.
2 GB.
Means automatically it will resize its file system.
What man?
Automatically, if first initially it is 32 MB, if
Hmm.
it is crossing it, it will automatically resize it to 64, and
Not resize. It
if
will
it is
create new file.
okay, okay,
It will leave the old file and it will create a new file.
okay,
Okay.
means that old 32 MB will be deleted, sir.
No, no, no. That will be there, man.
Okay,
It will create new file with a 64 MB.
okay,
Again, once that
okay.
is got filled, it will create new file with 128 MB.
Oh,
Like that, it will create.
okay, okay,
So, okay. Next is like mmap will use all the free memory which is there in the RAM for the MongoDB.
okay,
It's not
okay,
like
sir.
60%, 50%. It will use
Okay,
all the free memory from the RAM to MongoDB.
okay, okay,
And then in mmap, we do not have a concept called compression and locking at collection level.
okay.
It does the locking at see, sorry,
Doc.
not collect, not the document level locking. It is collection level locking.
Okay, okay,
Okay, this is how so when you are starting with the journal, it will display like journal directories. This is the journal directory, something like that. It will
okay,
display when you are starting that MongoDB.
okay, okay, sir.
Mm. So earlier version 2.4 journal will be by default it will be disabled, but after
Okay,
2.4 journal will be enabled by default. But
by
still
default.
if you
Okay,
want you can disable, but no one will
okay.
do no one will disable that journaling.
General, yes.
Yeah. Okay, next is in-memory storage engine.
Okay.
So we are done with WiredTiger storage engine and mmap storage engine.
Yes, sir.
So this is kind of a vast theory concepts. Initially you will have a lot of doubts or you will not understand clearly, but if you
Okay.
read 2 3 times this document you will know what it is. Okay.
Yes, sir.
So
Yes, sir.
what you will do today is you download I'll send you this PPT. You will look into
Okay,
this
sir.
this theory part,
Okay,
and
sir.
you come up with if you have any doubts or queries. Okay, I'll
Yes, sir.
clarify
Yes, sir.
you.
Yes, sir.
So this next is in-memory storage engines. I haven't seen any of our organization, any of our application teams are using in-memory storage engine, but still some use cases need this kind of in-memory storage engine.
Storage engines.
Yeah, what
Okay, sir.
in-memory storage engine means all the data and indexes will be kept into the RAM memory. But if
Okay.
something goes wrong to the server, then data will be lost.
Lost.
Yeah, because you do not have any file system level storage. Because you have
Yes.
everything in the RAM
RAM.
memory.
Okay.
Okay.
Okay, sir.
Mainly to get the performance benefits, they will be using this in-memory storage engines.
Okay.
So if something goes wrong, we will be losing this data. To avoid that, what we can do is, if you are, let's say, if you are using replication, like one primary
Okay.
and two secondaries,
Okay.
what you can do is, one you can do one primary and one secondary as a in-memory storage engine, and you can
Mm-hmm.
use WiredTiger storage engine for the another secondary.
Secondary. Okay.
Okay, so in that
Okay, sir.
case, you will have data in two server memory and one server file system level. Okay,
Okay.
even though if something goes wrong to the one primary, one secondary with the in-memory storage engine, so the data will be there in the WiredTiger storage engine of another secondary. So
Okay.
if you recover that other two nodes, so the data will be again fetched from the other secondary and it will be kept it in the memory.
Memory. Yes. Okay, sir.
You understood, right?
Yes, sir.
So this is how we can avoid those kind of problems.
Yeah. So basically, in-memory storage engines only are used only for read-only purposes, right, sir? Because for example, if you want if you go to some IRCTC or so,
Mm.
when you want to check some train timings or so, that will not be frequently changed, but that will be in memory storage engine, and everyone can quickly access the schedule whatever they want.
Yeah, you are right, but it's not like only you can do read in memory. You can do the
Ah,
writes as well.
right, as well. Yes.
But you have to make sure your server should not go get crashed.
Yes, sir.
If it is getting crashed, you have to make sure other secondaries are should be running properly. Then
Properly.
only that
Yes.
other secondaries will act as primary.
Yes, sir.
Okay.
Yeah. Sir, this in-memory storage engine, every time whenever the server is up, all the data will be written to
Yes.
RAM and kept over there,
Yes.
and everything will be updated in the RAM itself.
Yes.
But
Exactly.
when the server, if you want to shut down for maintenance purpose, then that that in-memory storage engine will write all the data from memory to the disk.
No, no, it will not write.
Okay.
So for that only you need to have one primary, two secondary, something like that. If you want to do
Okay.
maintenance on the primary, you should
Okay.
start the other secondaries as a primary,
Okay.
and then you can do maintenance on the old primary.
Okay. Okay, sir.
Like that you can do.
Okay, sir.
Got it?
Yes, sir.
So this is kind of a sample configuration. Storage engine,
Configuration.
you have to mention like in memory and DB
Okay.
path. So why we are mentioning DB path means, so even though data and indexes are there in the memory, still some
Yeah.
metadata and other miscellaneous information you need to store in the
Okay.
file system. So for that
Okay, sir.
we need to mention the DB path.
DB path.
Okay, so it will not be
Okay,
useful
sir.
to store the data files, but to store some metadata. Okay,
Okay, sir. Okay.
and in memory size GB means, so how much GB you want to allocate to your database.
Okay, sir.
You have to make sure that memory is enough to store all the data and indexes. If the memory is
Okay,
not
sir.
enough, then you will get error.
Okay.
Clear, right?
Yes, sir.
So we are done with the storage engine part, man.
Okay, sir.
So next we are moving to capture collection. Actually, this
Okay.
capture collection and TTL indexes will not come into the picture of architecture, but still
Okay.
I thought these are all two things I cannot put anywhere. Like these are all comes
Okay.
under the collection spot. We have talked about this yesterday, right?
Yeah.
Yeah. This is two type of collections
Uh-huh.
we have in MongoDB. So what is capped collection means? Circular buffer, right? What the circular buffer
Yes, sir.
will do?
Means once if one of the buffer is filled up, then it will write to the, if archive log is enabled, it will write to the archive log, and it will be like next log will be used. In the meantime, next log will be used. All this filled up log will be written to the archive log, and after this the second is filled, and this again that first will be again erased, and it will be start using the first one.
Yeah, similar to that, it is a one collection. Collection means it's similar to table. It is one.
Yeah.
It is one type of collection. In that collection, you
Okay.
can insert documents continuously. Okay,
Okay.
you can mention maximum size, maximum number of documents, or maximum size of
Okay.
the collection. Okay,
Okay.
let's say I'm creating one collection as a capped collection with the number of
Okay.
documents is 500. Okay, I'm start inserting
Okay.
documents. If
Okay, sir.
when I am inserting document number 501, what it will do
Okay.
is it will delete the first document.
Okay. Okay.
Okay, when you insert
Oh,
the document 502, it will delete the
okay.
second document. So
Okay.
like that, it will delete the old documents. It
Okay.
will
Okay, sir.
automatically delete.
Okay.
There are some threads will be running in the background. It will keep on
Okay.
checking what is the number of documents, what is the, whenever the insert happens, it's kind of a trigger. In Oracle, we'll be
Okay.
writing some triggers to check
Okay.
and delete the data from the table. So like that,
Okay.
MongoDB themselves, they have created this capped collection for
Okay.
deleting the absolute data. Like
Okay.
in which scenario we can use, let's say we are storing log information. Uh,
Okay.
so we know it is a log information. We do not need logs which are older than 4 days. Okay.
Okay.
So we can
Okay, sir.
calculate like for 4 days, normally we will be getting 10,000 documents. So you can set
Okay.
the maximum numbers as 10,000. So whenever
Okay.
the old documents or new documents comes, the old documents, the 4 days before the documents will get erased.
Okay.
Like that you can set.
Okay, sir. Sir, even MongoDB has a front end like as our Oracle has like OEM type.
Yeah, yeah, we have MMS manager.
Okay. Okay. Okay.
So anyway, we have a different section to talk about the MMS
Ah,
manager. That time I will
okay.
show you demo how to use MMS manager and other things.
Okay, sir. Okay, sir.
Okay, this is how the capital collection will work.
Okay.
So we can create capital collection in two ways. One is
Oh,
mentioning the number of documents. Next is
okay.
mentioning the size of the document.
Okay.
Okay, even if the I mean, let's say I am creating a document with I'm creating a collection with 5 MB. Okay,
Okay.
whenever the 5 MB get reaches and the new documents comes, the old documents get removed.
Okay. Okay, sir.
It's up to you whether you want to use size or numbers, or you can use
Okay.
both.
Okay, sir. So in the second example, we can say like if it is reaching 5 MB, then that the old documents will be removed one by one, or else max of 5,000.
So the preference will be given to max of size.
Max of size. Okay.
Yeah. Before it reaches the 5,000 numbers, if it is reaches
Okay.
the size, what is the size? 5 KB, it is 5 MB, I guess.
5 MB.
Yeah, 5 MB. If it reaches 5 MB, then it will remove the old documents. It will not wait for the
Okay.
maximum number of documents.
Okay, sir.
So this is how we'll be creating a collection. So yesterday we
Okay.
have seen, yesterday we have created collections when we are doing insert, right?
Yes, sir.
But we have uh, there was one option like explicitly creating collection, like using
Yes, sir.
db.create collection we can create collection like that. I have told you yesterday, right?
Yes, sir. Yes,
So
sir.
this is the process of creating the collection explicitly. You
Express
can
it.
create the
Okay. Okay.
collection with the collection name. You can mention,
Okay.
this is options like whether you want to make it as a capped collection or not. If you give capped
Okay, sir.
colon 2, it will be created as a capped collection.
Capped connections. Okay.
Yeah. So we'll practice this.
Okay, sir.
Uh, Before that, we'll finish this theory part. Okay.
Theory part.
Okay.
Yes, sir. Yes, sir. Yes.
And this is how you will check whether the collection is capped or not. If you give db
Okay.
dot collection name dot is capped, then
Okay.
it will tell
Show
you
all the
whether it is,
capped collections.
yeah. And then if you want to change existing collection to a capped collection, let's say existing
Okay.
we have a normal collection we have created. If you want to change it to
Okay.
a capped collection, you can use this run command. Actually
Okay.
this is admin command. This is kind of a administrator command.
Okay, sir.
db.run command, inside that you can mention whatever the operation you want to perform.
Okay, sir.
So db.run command, inside there I am telling like convert to capped and then collection name and then size I am
Okay.
mentioning. Here you can mention the maximum number of document also.
Okay, sir.
Okay.
Yeah.
Okay. So only you can do the updates within the size. Let's say you have mentioned 5
Oh,
MB. Um,
okay.
your current collection size is 4 MB. Then you can do
Okay.
updates. But let's say if your collection is already reached 5 MB, but still you want to
Okay.
update, and then the update makes that collection to 5.1 MB, then that updates will be failed.
Okay. Uh-huh.
Okay. Another thing is you cannot delete any documents from the capped collection.
Okay.
You cannot manually delete any documents from the capped collection. Okay.
Okay, sir.
But if you want,
Okay,
you
sir.
can drop the whole collection.
Whole collection. Okay.
Yeah. Only that when it get expires, that time only it will get deleted automatically.
Okay.
Also, you cannot do the sharding for the capped collection. Generally,
Okay.
we'll be doing sharding for a collection. It means like splitting the data to a multiple servers.
Yes, sir.
But you cannot shard the capped collection.
Yeah. So by seeing all these things, only capped collection is only created for server logs or log types of
Yeah.
files.
Most of these cases.
Yeah, because we can't update beyond that.
Yes, exactly. So it's a let's say you can tell like this. It is used to only for accepting all the inserts like logs
Okay.
and all server logs. we'll be getting only insert, right? No updates.
Insert, yes, sir. Yes, sir.
Yeah. For that kind of use cases, you can use this capture collection.
Okay, sir.
An example of capture collection is oplog collections. This oplog collections will come into picture in the topic of replication. In replication, this
Replication.
oplogs will play major role.
Okay, sir.
So this is by default MongoDB created collection. So this will be created only if you enable replication. As of now,
Okay.
we have not enabled replication. Okay.
Okay, sir.
So we do not have any oplog collection.
Yeah.
So next is TTL index. What is TTL
Okay.
index means? It is similar to capture collection, but it will slightly
Okay.
differ. So what is
Okay.
TTL means? Time to live. So how
Okay.
long that document should live in the collection? That is called a TTL.
Okay.
So what it is means? How many seconds you want the document to be live?
Yeah.
You can create one collection. For that you can create one index. You can mention some seconds. Okay. Like we have mentioned
Okay.
like 3600 seconds. It means
Okay.
uh,
For 1 minute.
1 minute, right? So
Yeah.
so whichever the documents created 1 minute before, it should get deleted automatically.
Okay.
There we have seen about size and the maximum number of documents, but here it is about time.
Yeah.
You understood?
Oh,
So also there we have mentioned the options while creating the collection, but here you have to give these options while creating the index. You have to create a
okay.
collection, normal collection,
Okay.
but while creating the index, you have to mention the expire after seconds.
After
After
6.
how
Okay.
many seconds that document should get expired, you have to
Okay.
mention.
Okay, sir.
So a background thread will be running. It will keep on checking every document whether it is paused that expire seconds or not. If it is paused,
Okay.
then it will delete the document.
Okay.
This is also used similar kind of use cases like machine generated event logs,
Okay.
session informations. Generally, you will not need those kind of information after some seconds, after some hours, right?
Yes, sir.
Temporarily, we will be needing those kind of data. So for that
Yes, sir.
scenario, you can use this TTL index.
Yeah.
TTL index means time to live index. Okay.
Index.
So TTL index is about time and the capped collection is about number of documents and the size of the document, size of the collection.
That, yes, sir.
Okay. Before talking about GridFS, this is the last theory part in our session. We will
Yes,
practice
sir.
that capped collection and TTL index and we will come to here. Okay.
Okay, okay, sir.
Because we have seen lot of theory part today.
Yeah.
So how do you feel? Is it feel easy or complicated?
When it compares to as of now, when it compared to Oracle, it is very easy, sir.
Yeah.
I don't know what is the depth of it, but till now it is very easy.
Yeah. Okay. I'm creating one capped collection.
Okay.
Here they have mentioned size, but I would like to mention number of documents. Okay. Because size means we cannot insert that much data
Yes, sir. Yes, sir.
to practice. So I'm mentioning
Max.
max and I will mention, let's say, two
Two.
documents. Okay.
Okay, sir.
So I am just listing the databases we have.
Databases.
Yeah,
Useful.
cap test. Okay, I am creating one database
Yeah.
called cap test.
Okay.
Inside there I am creating this cap data collection.
Okay, sir.
There are some errors. There may be syntax error. I don't know whether it is. I think we need to use max with size, I guess.
Yes, sir.
I think so, but anyway, I'll try this. Yes. Okay. Let's say 1 KB. Okay.
Okay, sir.
Created.
Yeah.
I think this symbol is the problem. If you see
Okay, okay, sir.
starting with the server log,
Yes, yes, sir.
yeah, since we have copied from the document,
Documents.
yeah, it was something wrong.
Means it will take without size also?
We'll try that. Well,
Yeah.
I think we need to delete, delete. Hmm. When you say capped is true, you need to mention size as well.
Okay.
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 So collections, you have one collection cap 1 with the
Cap
size
one, yes,
of
sir.
1 KB and maximum number of documents are 2. Okay.
Two.
I'm doing inserts
DB dot insert.
cap
Yeah.
1 dot insert.
Dot insert.
You can do anything, right?
Yes, sir.
Yeah, I'm putting just name
Name.
Siva.
Yeah.
Just a minute, I'm getting one call.
Yes, sir. Yes.
Ravi?
Yes, sir.
Okay. We will insert another document.
Yeah. Sir, your battery is low, sir.
Yeah, yes, man. I'll see.
Yeah.
We'll finish this one and then I'll put charge.
Yeah. Yeah.
Okay, I have
Yeah.
inserted 3 documents. Okay,
Yes. Yeah.
let's see the output.
And
We have only 2.
two. First one it has
First one
been
is got
deleted.
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 Okay, you understood, right? What is capture collection?
Yes, sir. Yes. Yes, sir. Yes, sir.
Okay, man, that's all about capture collection, and we'll see
Oh, yeah.
what it is. Also, if you want to if you want to display the all the capture collection
Uh-huh.
in the descending order.
Okay.
Okay, which one is recently inserted, like that,
Okay.
you can use this option.
Okay. Sort natural.
Colon, like this you can
Okay, sir.
you see Raja we have inserted at last, right? The
Yes, sir.
recent which I have inserted is Raja. After that we have
Yes.
inserted Ravi.
Yes, sir.
So if you want in the descending order, if you want to display all the documents which are inserted in the descending order,
Okay.
you have to use $natural colon -1,
Okay.
because by default this object ID will have the creation time.
Yes, sir.
Based on that, it will return the documents.
Okay. That plus one will be like
Yeah, if you want
ascending.
in ascending order, not +1, you have to use 1.
Uh, one. Okay.
It will Ravi
Okay.
Raja.
Okay.
Like
Okay.
that you can use. Okay.
Okay, sir.
And this is converting the normal collection to captive collection. Maybe you can
Yes,
try
sir.
this as a home. Maybe you can practice this and then you can come.
Yes, sir. Yes, sir.
Okay. Next
Yeah.
is like TTL index, right?
TTL index.
So okay, for that we will create one normal collection.
Yeah.
For creating normal collection, what do you have to do?
Insert.
No,
No,
db dot
db
collection name.
dot create
Either you
create,
can use create collection.
or else directly you can use a name also.
Yeah, name also. Now, if you insert any data, it will directly create it.
Yes, sir.
Hmm. Let's say TTL test or
Yes.
TTL, just TTL will.
Okay, sir. Insert.
So for having a TTL index, we need to have at least one date column, I think, or one date field you need to have.
Okay, sir.
Um,
Date or time?
a date or I mean timestamp field you need to have.
Yeah, yeah.
Let's say without timestamp field, I will test. If it not works, then we'll try with
Insert.
okay, I've inserted 3 records,
Okay.
db.ttl.find. So we have inserted 3 records.
Okay.
For that we'll create one index. So anyway, underscore ID is a timestamp field as well, right?
Timestamp.
Yeah,
Yes, sir.
I am trying to create one index.
Okay.
If you type few characters and if you uh, click tab, it will
Display.
automatically display the and other characters
Okay.
if you are typing correctly.
Okay.
So I am trying to create index for the field of but mm, let's say we'll try to create index mm, underscore id colon 1. Okay. By default for underscore id index will be created, right? So
Okay,
we
sir.
are not allowed to create index again for the same field.
Okay.
So what we can do is we'll try to create index for the field x,
Okay.
but generally it will not work, I guess, because as per TTL index concept we should have index for the field with the timestamp.
Okay. Okay.
Created collection automatically for. So index is created, but let's see.
Dot find get index.
So if you see, there are two indexes are there. First index is for the key of id underscore id.
Okay, sir.
Its name is underscore id underscore that index name.
Okay.
It is created for cap test database for TTL
Okay.
collection. Again, this is one we have created for the field of x.
Okay.
We have
X.
mentioned expire after some seconds. So
Okay,
let's
sir.
see whether it is working or not. I think it will not work.
I think we have to give it as 60 seconds, sir. We
Hmm,
have given 3,600 seconds.
that means 1 minute, right?
Not 1 minute. It's 1 hour.
Oh,
60.
3000 seconds means uh, 60 minutes. Oh, yes, it is 1 hour, right?
Yes, sir.
Okay, okay, okay. I think we have to drop the index first.
Okay.
So I'll tell you how to drop the index. db dot
Okay.
collection name dot drop index,
Drop index.
and then we need to mention the index name. It is x underscore 1.
Okay. Index name it is giving. No, sir. We are not giving it.
Index name. This is the index name.
No, no. Before that,
While creating, huh?
yeah, yeah.
While creating, we do not need to give the index name. It will
Okay.
automatically take some names. But still, if you
Yeah.
want, you can give some names.
Okay.
1 minute, I will put charge.
Okay, boss.
Okay, now we'll check how many indexes are there.
Yeah.
So only one index is there.
Yeah.
Other one we have dropped. Again we'll create index with seconds, right? We'll create with 60 seconds.
Okay.
I think it will not work, I guess,
Why, sir?
because as per a TTL index concept, we need to create index only for the timestamp field. But
Okay.
here we do not have any timestamps field. The underscore ID is it's something different. That is default
Okay.
one. Apart from that,
Yes,
we
sir.
need to create. We need to insert few field. Other field with the timestamp data.
Yeah. Yeah.
So that's why the data is not getting deleted.
Okay.
It's still there. So what we'll do is we'll uh, here we will be having how to create. Okay. Because this and all developer area, we will not be
Ah, yes,
generally
sir.
creating collections.
Yes, sir. Sir, this manual, if you want to download, if you click that download, it is going for the software download, sir, not the manual download.
Oh, okay, okay. But there will be some option, man, to download this PDF.
Okay.
Download this as PDF. I'll check and tell you.
Okay, sir.
Next, field. See, options on field whose values either date or an array of date values.
Date values. Okay.
Yeah. So you have to insert this like this.
Okay. New date.
Like this you need to insert.
Where is equal to new timestamp.
Okay, what we'll do is we will insert few fields. Um,
With timestamp.
yeah, with the date or timestamp
Okay.
date. You try with the timestamp tomorrow. Okay.
Oh, okay, sir.
Now I am trying with this one. TTL dot insert. Okay.
Yeah.
X colon 6. So 5 records will not get deleted, I guess, because and and C date, create date. I'll
Okay.
put it as C date.
Okay.
Okay. Okay. Before that, I need to. So 5 records are there.
Yes, sir.
I've set the variable.
Okay.
and I am doing the insert with the variable inserted.
Okay. Yeah.
So again we'll do insert. Again we'll set the new date. Again I'll do insert. After some seconds,
Okay, sir.
so now we will check how many. So these are the three records we have inserted
Okay.
now.
Yes, sir.
We need to create index for this field, right?
Yeah. C date 1 means, oh, sir, I have given 3600.
Oh man.
Drop. Index.
We don't know the index name, right?
Yeah. Get index.
We are doing mistakes only. We'll get familiar with the comments.
Yes, sir. Index. Sir, TTL drop index.
Oh, what man? Oh,
DB dot
yeah, yeah, yeah.
TTL dot
Right, right, right.
dot drop index. X underscore 1. Not X, the C underscore, yeah.
I think we not. It should not give the brackets.
C date underscore 1.
So it is dropped.
Okay.
We'll create it again with the 60 seconds.
Okay. Sir, C date colon 1 is the index name, right?
Underscore one.
Yeah, yeah. Means you are giving TTL create index C date colon 1 expiry after 60.
Yeah, yeah. This is like for which field we need to create index, and this
Okay,
colon one is whether you need to have a ascending index or a descending index.
descending index. Okay.
In Oracle and all we do not have like that, but here we have
Yeah,
option like ascending or descending. Colon one means it
descending.
is
Okay.
ascending.
Okay, sir.
So if you see Ravi,
Yeah,
initially
sir. Yes, sir.
we had this three
Yes,
fields.
sir.
It is got removed
Yes, sir.
after we are creating the index.
Yes, sir.
You understood, right?
Yes, sir.
So this is how that TTL will work.
Okay, sir.
Okay, man. So this one grid bus will start
Tomorrow.
next session. Okay, because
Yeah.
again it's simple topic only, but we'll talk
Okay, sir.
in next session. Okay.
Okay, sir.
Already we are
Okay,
done
sir.
with 2 hours today, I guess.
Yes, sir. Yes, sir.
Um, okay, man. Practice this capture collection TTL index and try to read about storage engines again.
Okay,
He
sir.
you will come with some doubts.
Yeah.
Okay, we'll
Yes.
see. And Ravi, tomorrow actually I'm going for Dindivanam for one of my marriage, friend marriage.
Okay.
So I cannot take session tomorrow because I'll be leaving morning earlier and I'll be coming after 2 p.m. That time I need to go to office for the shift.
Okay. Okay, sir.
So what we'll do
Okay,
is
sir.